There's beer on the other side of this talk.
So, hi guys. A little introduction about myself. There I am. I'm more like the freak of the group of the ATG that we are part of. It's Advanced Technology Group that's within HP Cloud. And our job usually is to go out, find something interesting, play with it just enough, and then tell some other people above us, hey, we should look at this. We should play with it. And that's what we've been doing a little bit with containers lately, because it's the hottest thing on the market. And this is Patrick.
Hi, I'm Patrick Galbraith. I have been with HP for 3.5 years. I've been in the open source, working in open source since 1994. I worked at Slashdot, worked at MySQL, worked at Classmates for a little while, and now at HP, Blue Gecko, a couple others. I come from kind of a database background. I had started out in Perl, still maintain the Perl MySQL driver. So for this talk that we're doing, I always look at something that is familiar to me to try out on this so that I understand it and can conceive of it. But that's who I am down there. I can see it down there, see it up there. Like to ski, like my tractor, like my kids. Love my kids.
Well, the purpose of our talk, as just said in the slide deck, is basically to figure out what can we do with Galera, CoreOS, and just the basis of using CoreOS. We didn't want to bring in Kubernetes. We didn't want to bring any other things really in, just to really expose what it was doing at the time. So we started down this road, and this is the basic little overview and synchronization. And Patrick did a lot of work on the containers for getting this up and running. And I did a lot of the work in the background trying to get a demo to work for you, which it's not where I'd like it because we had some problems. But the main things that are prerequisites are you need etcd, etc control, fleet control, and go. And what I had working is my laptop. One of these, we are using, I've been using Vagrant and spinning it up with VirtualBox. So I have a master. I'm running right now just one master of etcd. Makes development on the laptop a lot easier when you don't have too much memory to work with. Spin up one etcd. It doesn't need the whole quorum of everybody there. Then we have my minions. And they come in, and that's basically, they come in, and that's where we're spinning up the cluster for Galera. So you basically have seen this. We've heard what containers are, operating system levels of virtualization. Patrick can talk to this. He knows a little bit. He's been playing with this with the Kubernetes people a lot more lately than I have.
Yes, we all know what containers are. We're all here, and obviously we know what they are, and there have been many talks that have already covered this. For me, what containers have been, I first approached this from working with virtual machines, and I thought, okay, it's kind of just like a lightweight virtual machine. But after a year of going through that, I've realized, no, it's not quite that. Kelsey was talking to us earlier, and he put it into really good words. Really, I like how he described it, that it's like tarring something up and making it just like you would yum install something. You're installing it with a container, but not having to worry about dependency hell. And for me, the thing that I had to learn, I did a talk 2.5 weeks ago at Percona Live, totally different audience, an audience that's not as familiar with using containers to some degree. Definitely not Kubernetes or CoreOS crowd, but they were the people who went were very interested. I also met the Vitesse people, which I'll talk about at the end so that I don't take up too much time. But building a container is where it's really at with both Kubernetes and CoreOS. Having it have functionality inside of it when you start it up that can utilize whatever you pass it to use discovery information or to work with if you're bringing it up from a pod or a unit file that it knows what to do. So that's all, that's the thing that I would say about containers. This slide, some of this is from the talk I did earlier, and they needed to know what containers are, and obviously you know what they are.
We weren't sure what type of track we were actually getting into when we came. So then we have basically the understanding, virtual machines, containers. This is another slide from Patrick's deck.
This is a good one, actually, for people who come from a virtual machine background, particularly if you're working with people who work with VMware, or we work with a lot of people in the OpenStack community. Some of them don't yet. A lot of them really do know what containers are now. They definitely know what containers are. But originally, this was a good slide for getting the point across as to what the differences are.
Okay. Me being trying to be a little humorous. If we're here right now, I added that in because we're here. We understand what Docker is. You're really here probably to learn more about Rocket. Rocket wasn't on our roadmap when we first started out down this path because it was just really even pre-beta type of organ. It was just, here's the spec. We really we weren't ready to go down that path.
It's hard enough getting the things running that you need to get running, let alone throwing in another factor in there. That although it's a great piece of software, it's another factor. And if you're preparing a presentation, well, you definitely don't do live demos, and you definitely try to stick with things that.
And then we start going down this path. Yep. Oh my God, where'd this come from? We have so many pieces in this ecosystem of how do we get something up and running. Which one do you choose? Are we going to use Mesos? Are we using Kubernetes? What is the Kubernetes and Mesos mix right now? How are they interacting as, which one is the scheduler that you really want to use right now? I'm still in the area of trying to figure that out. Bringing up one, I can bring up the Kubernetes world. I've got that pretty much under control. The Mesos Marathon, haven't touched it yet because we've been focused on basically just understanding this and telling people that might be a CTO or a CEO nature of, give me the bare bones of this, because our customers, they come to HP and they go, give me Docker. I want Docker. Well, do you understand what Docker is? No, give me Docker. I want containers. Can you make it happen tomorrow? And that is something that we have to figure out. How do we get that into the customer's hand? But we are not the ones writing the code that is actually going to be in the production world. We're putting out a prototype, and hopefully they'll understand that internally at HP. So we also have this slide, which of course I did something also. Connecting it all together. So for our demo, we basically are just using etcd, Fleet, and Flannel. And this is where Patrick can talk again about what he did for the Galera
So cluster. We got some secret sauce here. So you know, you got the Galera. Well, what we put together was, I had a container that I built, Percona Extra DB cluster. It is Galera replication, and I had made it work so that it would run, put everything in it that it would run within Kubernetes. And for this talk, I added some more functionality to the entry point script to be able to get the fleet control endpoint, which is etcd, and set that. Also build into the container etcd itself. And then the entry point script. The entry point script does some pretty clever things. I think it's clever. It generates an SQL script. I worked off of the basic MySQL Docker official container, and it has an entry point script that just does some basic set up the root user and do a couple other basic things. I added to it functionality to add the SST user. SST, what is SST? SST is single state transfer. That's when you have your bootstrap node that comes up, a new node comes up and it says, give me, I'm connecting, please give me your single state, sends it over. Well, in order to do that, the node that it's connecting to has to be able to dump data, and it does that with a user. It needs a user to be able to do that. Not dump, I should say extra backup, which is different than MySQL dump. How many of you, I was going to ask this question earlier, how many of you work with MySQL or have worked with MySQL? Okay, out of you, how many work with Galera? Okay, so a fair sampling. Anyhow, there's also another user that has to be created, the cluster check user. Cluster check is a simple utility daemon that runs, that spits out on whatever port. In this case, we used 8000 because the one that comes stock with it uses ZynetD, and ZynetD on Docker wasn't working so great. Anyhow, that provides weather information to a haproxy whether or not the cluster is running. Also build a cluster.conf. That first, you want to know what your IP address is of the node you're connecting to. You also you can build up WSREP cluster address, which is a comma-separated list of the servers that are in the cluster that you're going to request SST from. And it gets that, of course, from etcd. Uses that discovery information. And also generate a random server ID. It also puts cluster check on each Galera node, runs it on port 8000. I'm using a Python cluster check because, as I mentioned, the one that is installed with Galera uses ZynetD, and I just had unreliable results with that, so I use the Python one. Then also we expose ports 3306, 4444, 4567, 4568, and 8000. The first port, of course, is the MySQL client port. The other 3 ports have to do with Galera replication, and then 8000, of course, is cluster check, as I mentioned. So the secret sauce for haproxy. haproxy is the other piece that makes this work. haproxy we use to be intelligent about which node in the Galera cluster, or we use round robin. In this case, in this example, we used round robin. There are some cases where you want to just always write to one particular node. And if there's a failure, you move to another one. But in this example, we used round robin. So I saw there was a slide earlier at another talk where he was talking about using confd on haproxy. Well, this is the very thing I did, because there was a great post that we did a demo internal in HP about 6 months ago, and I was using some work that a fellow named Marcel de Graaf did. He did an excellent post, really great Git repo with all the material and everything you need to know on how to run ELK on CoreOS. Anyway, I used some of his ideas for putting confd on this haproxy image, and so when this image comes up as a Docker container, confd connects to etcd and finds out what the Galera, the IP addresses of the Galera nodes are, and of course builds out the haproxy conf with that. And then it starts up cluster check on each node and determines the health. It uses that connection on each of the Galera nodes to know which one is still able to connect to and proxy to. In this case, I exposed 33006 as the MySQL client port, so that, you know, if whatever your application is, or if you're just using the MySQL client, that's where you connect to.
And so, for our demo purpose, we were going to do this, and I had some recordings of it. They go by a little quick, but here's what we were doing. We had the virtual box. We spin up the master first. The master then is basically just having our etcd. It's starting Flannel. It's also doing a Docker repo to cache Docker processes, or cache the Docker images, so I don't have to waste time downloading everything. And that's handy, especially on this network here. Then we bring up the next one, the core, and these keep coming up. And then finally, we start the processes. etcd starts coming out and creates the communication for etcd, where everyone knows that where I'm going to go talk to them. The core 1 through 3 all know where that endpoint is. They start also. Flannel starts up. It also comes out and has the Flannel network that we're going to assign the IPs, so each internal node has its own network and IPs, so we can do this across machines. And Galera comes up, talks to there.
That's a bootstrap node.
Comes up. It has an IP from the Flannel. And so that's where our replication for Galera is going to happen. And the sidekick is putting information into etcd about the private IP. So we will have the private IP of the Galera cluster, or the first one, Galera 1 in etcd. So when Galera 2 comes up, it's looking for that information to populate the variable. What is the Q? I can't always get the
WS rep cluster address.
WS cluster address. It's grabbing that and says, aha, I'm starting up. Nothing I have in my database right here is valid. Removes it, starts syncing back up to Galera 1. And when it finally is done, it's also now coming in and doing the sidekick and all that. Adds itself to the number, and we start continuing down the path. Each one starts doing the same thing. So now we have the cluster running, but it's still just talking to itself. It's all synced up. So the next one we bring up is an haproxy. The haproxy is going to be our interface to the world. It's going to expose the port to the outside world. We also can expose, if we want to, the haproxy management or statistics page, so you can manually pull out Galera from the proxy. So it's also getting information from there, creates up the haproxy area, replication. These are the checks that he was talking about before, about it's doing the cluster check. It's going through, connecting through down the same networking path and connecting to the Galera cluster on port 8000 and saying if it's okay, excellent, we'll keep you part of our check and we'll add you in the round robin load balancing. That's the basic setup right now, and this is all available. I'm going to give these slides over to the event at the end with some updates to the Git repos where this is right now. This is all in a Git repo. You'll be able to do one command, bring this up on a machine with enough horsepower and a good enough network, or enough network to actually download it quick enough to bring this up in a small test environment.
Yes, after I upload my slides to Percona Live that they're waiting on, you see I want to add a replication control. I didn't have that in my original talk. Anyway, this slide right here is not as exciting as this slide. It doesn't animate, but what I was trying to point out on here are all the bits and pieces and what's talking to what, to the best I can. I'm always fighting with these graphing tools. Every single one of them is terrible. Anyway, so what you have here is you can see 3 Galera nodes. The first bootstrap node that comes up, of course, as he mentioned, the sidekick is what puts the IP address of that node inside of etcd so that when Galera 2 comes up, gets a single state transfer, it knows where to go. The thing that I was working with him on this, and it was somewhat hard for me to comprehend in the beginning, way back when I started using Galera. WSWeb cluster address doesn't define membership. What it defines is where do I go to get single state transfer. Once you have that, you can add other nodes, and even if that isn't updated with that listing of all the nodes, Galera knows what is connected to it, and that can be reflected within the database. There's a status variable you can query to find out that everything's working. Anyway, haproxy makes use of these same entries that each node, when it was doing as its SST, also knows about. And it uses that using confd to generate the haproxy config. Then, of course, haproxy has in it the config file connecting to port 8000 on each node, talking to cluster check. And it says yes or no, whether everything's running. And haproxy adjusts accordingly. Then, of course, as I mentioned, to talk to this, port 33006, and that's how you talk to your cluster.
But what happens when disaster strikes and you lose one of those CoreOSs? The CoreOS, you lose number 2, CoreOS-02. What happens? Well, Fleet is still there saying, well, I still need to run Galera 2 somewhere. If I had another CoreOS 4, 5, or 6 hanging out just waiting there, it will go and try to put it on and schedule it onto one of those. And when it does that, it's also doing the same process. So it's updating etcd with the information for the replication. and starts adding it back in. We were able to kill off a node or go into VirtualBox and say, just stop it, destroy it, whatever. Everything there is gone. Bring up another provisioned CoreOS that is also joins up into Flannel, gets its IP, and it starts doing the job. And because of the confd and haproxy, it automatically gets added into the load balancer there. And it takes about, on a good network, it's a matter of how you do your time to live in your etcd, and also how quickly your check happens in your haproxy. And you can adjust that and tune it to your likes. But it's it makes it so it's really reliable, and without having a totally keep track of this and do it yourself scripting we used to try to do this with trying to have alerts coming through Isinga or Zabbix to then trigger a launch of a machine over here that, okay, do I have the right config? Was it the right thing on this time? And pull in the data. Now, this makes it a lot easier, and it's pretty reliable. There are little gotchas that probably would be improved, and definitely would be improved, I believe, by running this on top of, instead of going directly to Fleet, using kubelets and Kubernetes to have those as pods and deploy it that way. There's more intelligence there. There is the scheduling is a lot better. You might be able to talk to that.
Yeah, it's funny because I did this talk so that it would run on Kubernetes, and there were some things in Kubernetes I didn't take advantage of. I was short on time, and I didn't have time to put everything into a replication controller, but that's really the way to go. I did have the time to really get a feel for what services can do for you, and that really, when I went to do this, I was thinking, oh, I wish I had services. Oh, I wish I could do this. It worked a little differently when I made this work with Kubernetes, because what I had it do is it didn't go directly to etcd. I would have liked to have had time to learn Go and write a utility that queries the Kubernetes API and gets this information about the Galera cluster and uses that for auto discovery. What I did was I used bash, and I put kube control on the container, and I used that to read from the read-only Kubernetes API and find out for discovery, so that when each Galera node requested SST, that would work. And that was really nice. I really liked that. I really liked that model. I started really understanding the whole concept of using pods. The one thing you get out of this is that this is an extremely flexible environment, and it's a bit of a moving target right now, but there are numerous ways to solve these problems, and depending on what you prefer for your architecture and your development patterns and your environment, you can go either way. With going straight CoreOS, you're going to have to do a little more of the auto discovery yourself and maybe write some functionality to utilize that. But it just makes things so much easier. Yazz and I have done Galera. We did it with Chef 3 years ago.
Chef and Salt.
Then Salt Stack.
Yeah.
Then Ansible. So we've solved this a million times. Well, not a million times, but 4 or 5 times.
Yeah, at HP, before coming to the ATG, I was working with Platform as a Service, basically I deployed the infrastructure for Database as a Service. And that was me and one other person for the longest time, and then me alone, and then they went, well, we're going GA. Oh, overnight, one weekend, all of a sudden we got all of HP printing services running on it. It was a lot of fun.
So we've solved this problem a lot of times, and doing something like this, putting this type of application on either CoreOS or Kubernetes, it really gives you a chance to understand what value it adds and why you want to use it. I totally get it now.
So are there any questions real quick? We got maybe just a minute or 2 left. If you ask, we can. But if not, thank you. Thank you.